Hello and welcome to this demonstration of Gverse Attributes 2016.1. In this video, I will show you what you can do with the fault extraction attributes that are a part of our latest release. We have a new category of attributes in 2016.1 called structural highlighting that contains attributes that can assist with seismic data interpretation. Here we have the structure-oriented filter and the two fault attributes, fault tip and fault strike. Like all other attributes, these are also computed on the fly and results are instantly displayed in the viewers. The structure-oriented filter helps smooth your data to minimize noise while preserving the structural features. The fault dip and fault strike attributes highlight faults and assign a dip or strike value to each detected fault. Areas where there are no faults detected do not contain any data. Just looking at fault sticks hanging in the air is not really the best way to analyze the data, and Gverse Attributes provides you with a set of tools that can help speed up your analysis. The first of these is the secondary attribute that lets you overlay an attribute on top of the other. So I can set my filtered data as my primary attribute and select a region where I can overlay one of my fault attributes. Since the fault attribute has data only at the fault locations, I can see how well my detected faults relate to my actual data. You can move this around to see how your faults are looking in other areas. As with any other automatic detection algorithm, there are some false positives and some undetected faults. You can adjust the parameters like fault likelihood, allowable chaos, minimum length to detect, the dip and strike smoothing to fine-tune your results and get the perfect fault detection. Save your desired set of parameters and create your fault detection volume. You can add this new volume to your workspace as a pre-computed attribute as well. This helps in faster analysis, and you can also use voxel rendering to get a better look at your faults in 3D, as I will show you a little later on. Another useful and quick way to view faults on top of your seismic is to use co-blending. Co-blending lets you visualize two attributes simultaneously. In my fault overlay co-blending profile, I have input data in grayscale set as the base, and the fault tip with these parameters in a uniform red color palette as my overlay. You can easily visualize your faults and see how well the algorithm has done in picking your desired faults. Open up a time slice to see how the faults look in the horizontal view. You can also view these in 3D to get a better sense of the temporal and spatial alignments of your faults. Navigate in 3D with the co-blending applied to see faults in other areas of your dataset. You can also apply these to probes. I have one preloaded here with a cut applied to the first inline to get a better understanding of my structures. I can move the surfaces to get more insight as well. If you add a pre-computed fault volume to the workspace like I have here, you can also visualize the fault surfaces and what they look like. We are currently working on connecting these voxels to create actual fault surfaces automatically. Right now we can only visualize these in 3D, but we will have complete fault surface generation available soon. So this was a brief look at using the fault extraction attributes in Gverse Attributes 2016.1. Thank you for watching, and for more videos about this and other new features, please visit our website lmkr.com/gverse.